Hi students, because of the lockdown I am recording from home, you can see. Okay, it's lockdown, but that doesn't mean your studies should get affected. So we are here, back to the class. Now see, the concept which I am discussing today is basically on nucleophilic substitution and the elimination reactions. That is, we'll be discussing SN1 reaction, SN2 reaction, E1 and E2 reaction. How do they take place? In which condition do they take place? Who will compete and who will be the winner? And how there is always a war between whether it will be substitution nucleophilic or whether it will be an elimination reaction. And who decides basically what will happen, like maybe it's the solvent which we are using, maybe it's the type of the leaving or the attacking group in the molecule, or it may be the nature of the alkyl chain or the aryl chain which is participating in the reaction. So after the class, I think basically after this lecture, all your queries with respect to nucleophilic substitution, whether it is SN1, SN2 or elimination reactions, that is E1 and E2, will totally vanish. All the doubts will totally vanish. But in spite of that, if you find any doubt or something which you cannot understand what I am taking in the lecture, you can just drop a comment regarding it, or you can get back to me on my Facebook page, that is Simple Shukla's Private Tutorials, and we will take up your query and we can proceed accordingly. So let us begin. Now children, as you know, this is basically the concept from halogen derivatives of alkanes. I will just set the board, and I think the screen is very clear, the board is clear to you. Now see, one very important thing which you should take care over here, students, is in this lecture I'll be making use of certain terms that I'll be using for reactants and products. So the very first thing, I'll give you an idea about it. Say if I take A plus B, which is giving me the product C plus D. Now students, as you know very well that A and B are the reactants. They are the reactants, and C and D are generally referred to as the products. This is something which everyone knows, right? Now in the lecture I'll be using this term substrate for the reactant A, that is the main reactant, and I'll be calling B a reagent. That is, there are two reactants. The first one is the substrate. This is the alkyl chain or the aryl chain with the functional group, and the other is the reagent, which is actually the attacking molecule which will help to carry out the reaction. There will be some solvents which we'll be using, which I'm just writing here. Whichever solvent we'll use, we'll see that. And C is called the product, and D is basically called the byproduct. So whenever I say substrate, it is very clear I'm referring to A. When I say reagent, I'm talking about B, and when I say product, I mean C, and similarly for byproduct, I mean D. Okay. Now, such a reaction where A, B react to give C and D is generally belong to the category of substitution reactions, and usually with this C, whenever this C has a pi bond, then it is also called, then it is called elimination reaction. And if AB reacts to give CD, then it is a substitution reaction. But if C is having some pi bond in it, which is formed due to breaking of two sigma bonds, then such a reaction is called the elimination reaction. So once again I'm saying, with A I refer to substrate, with B I mean reagent, and whenever I say C I mean product, and I say D, it means the byproduct. Now, the next thing which we should know over here is, the next point which we should know is, how do we understand that it is the nucleophilic substitution or it's the elimination? How to understand that? So, let us see that. Let us understand how to get whether it is nucleophilic substitution or it is an elimination reaction. Now children, see, as you see on the board, the topic which we are discussing is halogen derivatives. So we'll basically stick to alkyl halide as the substrate. Over here, in halogen derivatives, we can take alkyl halide, that is haloalkanes, or we can take aryl halides as the substrate. Say for example, students, I take a molecule of ethyl bromide. I take a molecule of ethyl bromide and I treat it with KOH. That is the reagent. This is the substrate and this is the reagent. And the solvent which I am using is aqueous medium, that I am taking water molecule as the solvent. Aqueous, that means water. Now in this reaction we will be getting ethyl alcohol, that is this bond between C and Br is a bond whose electron pairs are more towards bromine. That is, bromine is attracting the electron pair and the electron goes to bromine and bromide is out as the leaving group, and the K plus from here makes a bond with it, and that is the bioproduct. This is a nucleophilic substitution reaction, children, where the weak nucleophile Br minus is replaced by a strong nucleophile OH minus. Now let us see in the same reaction what will happen during elimination. I again take a molecule of ethyl bromide and I treat it with KOH again, exactly same reagent. But children, I am changing the solvent. I am making use of alcoholic medium and not aqueous medium. Now in the alcoholic medium, what we find is this OH doesn't replace bromine, but it attacks over here, and it abstracts this proton. Let us understand the molecule of ethyl bromide. Carbon carrying halogen, as you all know, carbon carrying halogen is known as the alpha carbon, while the carbon adjacent to alpha carbon is called the beta carbon. Among carbon and hydrogen, carbon being more electronegative, when this lone pair on oxygen approaches hydrogen, then it approaches hydrogen, who is actually released as a proton, and the negative charge, that is the two electrons of the bond, are attracted and withdrawn by carbon, and these two electrons then make a pi bond and we get the structure as ethene, where two sigma bonds have broken, to give us one pi bond. This is an elimination reaction, students. This is not nucleophilic substitution. So in a nucleophilic substitution, the weak nucleophile Br minus is replaced by a strong nucleophile OH minus, and we call it nucleophilic substitution reaction. Whereas in elimination reaction, the KOH base abstracts a beta hydrogen, which makes a pi bond, that is two sigma bonds break to form one pi bond, and this reaction is called the elimination reaction. I hope students till here it is clear. Now we move ahead with the next point. Whenever I was talking here, I said the nucleophile, the strong nucleophile OH minus replaces weak nucleophile Br minus. Whereas here every time I was saying when the base attacks
although the molecules are same. Here I am calling it a nucleophile, there I am calling it a base. Let us see how does that differ and how to understand that the same species can behave as a nucleophile and can behave as a base also. So what do we understand by the term nucleophile and the base? What is the meaning of nucleophile and what is the meaning of a base? Let us see, children. Now nucleophile, the term nucleo means nucleus, and the term phile or philic means loving. So when I say nucleophile, I mean some species which is nucleus loving. Correct. We all know, students, nucleus is positively charged and hence this is a species which is positive loving. Just take care what I am saying. I didn't say this is a positive species. I said this is a species which loves a positive, and hence it is very clear, student, that it itself must be negative. So itself, it is a anion. Itself, it is a negatively charged substance or the ion, or it is a neutral molecule which is having the lone pair which it can donate to the other species which is positive. Other species is positive, itself it is negative, so negative loves positive. This is the meaning of the term nucleophile. And hence I can say nucleophiles are electron rich species. And they donate lone pairs, so they are nothing but the Lewis bases. And whenever I'll say nucleophile, I will use the symbol Nu minus or Nu dot dot to represent it. Okay? Now children, let us understand what do we mean when we say base. Now, as we have learned many times in the class also, that there are 3 theories to understand bases. I hope you remember, but still, whatever, we just have a quick look at it. Students, there are 3 theories. One of the theory is Arrhenius theory. According to this theory, base is a substance which accepts proton. So according to Arrhenius theory, base is a proton acceptor. According to Arrhenius theory, base is a proton acceptor. No children, here we are not correct. This is not Arrhenius theory. According to Arrhenius theory, students, base is a substance which will produce hydroxyl ions in the solution. Base is a substance which will produce hydroxyl ions in aqueous solution. यानी वो सब्सटेंस जो पानी में OH माइनस आयन देगा उसको बेस कहते हैं. दूसरा थियरी है Bronsted-Lowry theory. The other theory is the Bronsted-Lowry theory. According to this theory, base is a proton acceptor. इस theory के अनुसार base is a proton acceptor. And my dear student, the last theory to understand the bases is the Lewis theory, according to which base is a lone pair donor. Base is a lone pair donor. So see, according to Arrhenius theory, this substance can behave as a Lewis base. Base is a lone pair donor. Only we should understand when and under which conditions a substance can behave as a nucleophile and in which condition the same substance can behave as a base. Now we proceed further, children, with this. Let us proceed further. Let us move next. See what happens. Now here, suppose I take a molecule of 2-bromobutane and I treat it with a nucleophile. Right? Again, I take the same molecule. Taking the same molecule, or we just see one below the other. I treat 2-bromobutane with the nucleophile. So what will happen? The nucleophile itself will come and it will displace Br minus. So the weak nucleophile Br minus is replaced by the strong nucleophile, and that is NO minus, which can be any strong nucleophile. But when the same reaction I am doing and I am writing above the arrow base. Now in this situation, students, I will be getting a alkene where 2 sigma bonds will break, cut. 2 sigma bonds will break to give me 1 pi bond. Now if you look at it carefully, this pi bond can come here also, because H can be removed from the terminal carbon also, and we can also have one more product over here, which is this. But as we know, the Sitzeff's rule, the rule states alkene which is more substituted is major. As you see, this alkene is more substituted. It has 2 alkyl branches, 2 alkyl side groups, whereas this alkene is less substituted. It has only 1 group, that is ethyl, while this has 2 groups, that is methyl here and a methyl here. So this is the major product while this is the minor product. So that is in accordance with Sitzeff's rule, which states that more substituted alkene is the major product during elimination. Now what we should understand when this will happen and when this will happen. See, I am using KOH here, I am using KOH here also. But here KOH behaves as a nucleophile and gives me substitution product. But here the same KOH behaves as a base and gives me the elimination product, that is an alkene. The difference is in the medium of reaction. This reaction I am carrying out in aqueous medium, while students this reaction I am carrying out in presence of alcohol, say ethanol, ETOH. Now what we should know is next, why it is this way, that in aqueous medium substitution is taking place, but in alcoholic medium elimination is taking place. So let us see that. So now we are coming to a very important concept. That is very modern, really very modern, very modern. And that is, why aqueous medium? Why nucleophilic substitution? See how I read it. Substitution, nucleophilic substitution. Why nucleophilic substitution in aqueous medium? Correct? And why? Why elimination? E is for elimination in ETOH, alcoholic medium. Let us see that. Now, students, take care. Look at the board. Be very, very attentive. Now, as you see here, the aqueous medium and the alcoholic medium, see, the very first thing, suppose when I take KOH, okay, suppose I'm taking KOH, and the medium is aqueous, that is water. The very first thing which we should understand, children, over here is, this is inorganic, this is inorganic. And we know the principle of solubility. Like dissolves like. Inorganic will dissolve easily in inorganic. Not only that, this is a polar molecule. This is electronegative, this is electropositive. This is also a good polar molecule. Also, it is inorganic. Water is a universal polar solvent. So, like dissolves like. So, this just undergoes ionization. KOH ionizes to give K plus and OH minus ion. Now, forming K plus and OH minus is not a big deal. Okay, this is a nucleophile and this is an electrophile. Fine, it got splitted into K plus and OH minus. But what we should understand here, this water molecule over here, the water molecule over here will help me to keep OH minus in its strong OH minus form, and that nucleophile will help me to do nucleophilic substitution. Now, first thing, KOH in aqueous medium undergoes ionization to give me OH minus, and this OH minus gets surrounded by water molecules. See how the water surrounds this OH minus like this. This is a molecule of water. Same thing here, students. See how the molecule of water is getting attracted to OH from all sides, and it is not allowing OH minus to combine back with K plus and make KOH, but the OH minus is stabilized. Again here, this is how it is making bond with water. Same thing here. See how it is making bond with a molecule of water. Again here, a molecule of water. So see how well water molecule is surrounding this OH minus from all sides, and the OH minus gets completely hydrated. Because it is hydrated, because it is OH minus, what can happen? OH minus can take a proton from water. Okay, it has formed intermolecular hydrogen bond with water. Suppose it takes a proton from water. Say this electron pair goes to oxygen being more electronegative, and this negative makes a bond with proton. So what big deal? This OH will become water and that water will become OH minus. So anyhow, student, OH minus is existing. The nucleophile is existing in aqueous medium, and this nucleophile will quickly attack the carbon, because carbon will be positive here and bromine is negative here, because electron pair will shift towards bromine, and hence nucleophilic substitution will take place very easily in water. But when elimination is taking place, what you should understand, first of all, why elimination doesn't take place here. Elimination doesn't take place because OH minus is already hydrated.
It's hydrated. It can take hydrogen from water. It is absorbing entire water into it. So why it will undergo elimination? See what happens in a elimination is this once again I am writing. We just saw it some time back. See what happens in an elimination. I'll just write a little bit the size so you can clearly see the bird. Now see in elimination what happens? OH minus should abstract this proton. But why will it do so? In aqueous medium, it is already hydrated. It is having so much water. It can take proton. It can become water, and water can become OH minus. So why it will abstract a proton? So in aqueous medium, the OH minus is hydrated, and hence it is not in a position to abstract proton from beta carbon. But in alcoholic medium, the OH minus is not hydrated, and hence it is in a position to abstract a proton from the beta carbon and cause elimination reaction. So the same OH is over here behaving as a base, but the same OH over here is behaving as a nucleophile. Now, I hope this is clear. I'll just wait for some 4-5 seconds. You can have a look at the board and then we proceed further with SN1 and SN2 reactions and E1 and the E2 reactions. Okay students, now see, so far it is very clear to you that why in aqueous medium it is substitution nucleophilic, but in ethanolic medium, alcoholic medium, it is elimination reaction. Now we proceed further. We see in detail what is substitution nucleophilic and how does it take place. Okay, now see. In substitution nucleophilic reactions, we have two categories of reaction. They are SN1 reaction and the SN1 reaction and the SN2 reaction. We have two types of reactions, the SN1 and the SN2 reaction. I hope now it's clear to everyone. Yeah, this is SN1 and this is SN2. SN1 and SN2. Now what we have to understand is what is SN1, SN2 first of all. Okay, let us take first the SN1 reaction. Students, in SN1 reaction, what happens is, okay, even before that, what I would like you to understand is the meaning of the terms, okay? S stands for substitution. S stands for substitution. By the time I write, you can revise. S stands for substitution. N stands for nucleophile. Or the nucleophilic. And 1 simply indicates unimolecular. That is monomolecular. Or the first order kinetics. The first order reaction having first order kinetics. By first order kinetics we mean that rate of this reaction will be directly proportional only to the molar concentration, that is moles per liter, or the active mass of substrate. And students, I hope you know what is substrate over here. Obviously it is the haloalkane, because when we begin I gave you that. You can just move behind and check if you don't remember. So SN1 means rate of this reaction will depend only on the substrate. Now, what kind of alkyl halide should be there so that
the rate depends only on the substrate. Let us see that. Basically, here the alkyl halide will be tertiary. We'll also see why, but first we'll just collect all the information, what all is required. Why was it required? We'll come to that. But first, let us just collect the information. So, say if I take third butyl bromide and I treat it with KOH, which is aqueous, as you know, substitution nucleophilic, and I heat the molecule a little bit, I warm the condense, then I'll be getting third butyl alcohol, that is 2-methyl propan 2-ol, and the byproduct is KBr. So this is the substrate, 2-bromo 2-methyl propane. This is the reagent, this is the product, this is the byproduct, that is A plus B gives C plus D. So rate of this reaction will be directly proportional only to the molar concentration of the substrate, and that is Chhatri thrice CBr, that is the 2-bromo 2-methyl propane. Okay, we're just collecting the information right now. Now, since the rate depends only on one type of molecule, not one in number, one type of molecule, that is the substrate, it is called unimolecular rate dependent, other monomolecular rate dependent, or the first order kinetics, that is first order rate of reaction. Now the next thing which is required over here is how many steps in this reaction. See children, SN1 reaction takes place, we are discussing SN1. SN1 reaction takes place in 2 steps. SN1 reaction takes place in 2 steps. Let us see what is step 1. Step 1. Student, in step 1 there is breaking off. There is breaking off CBr bond. In step 1 there is breaking off the CBr bond. Breaking off CBr bond. Why and how the CBr bond breaks? Let us see that. As we know that here we are taking third butyl bromide. Now see student, if you be very attentive, then you will see over here that this substrate which is tertiary in nature, having a very bulky alkyl group, a large alkyl group, that is a bulky alkyl group, third butyl, the nucleophile over here cannot attack from the back side. Suppose I take a nucleophile, I want to approach this molecule, then it cannot attack from back side because third butyl is a bulky group, and a bulky group causes steric hindrance, that is, it doesn't allow the reagent to attack it due to overcrowding of the alkyl group, that is the 3-methyl groups which are creating overcrowding here, which is called steric hindrance. So the bulky group hinders this OH minus to attack from the back. So the moment it approaches from the back, it's thrown away. Similarly, children, OH minus can also not attack from the front because bromine is also electronegative. So when OH minus approaches from the front, it is thrown away. Now it is very clear that OH minus in a bulky alkyl group, that is a alkyl halide having a larger alkyl, a branched alkyl group, the OH minus cannot attack from the front side, cannot attack from the back side, and hence it's very clear why I need to take more OH only when it cannot attack the molecule. It cannot initiate the process. So here we know we need very less quantity of OH minus, and we will take excess of water. We need more water, more polar solvent is required over here. Now what will happen in this when we take a polar solvent? See, we know the CBr bond is a polar bond. I hope children you know what is the meaning of polar. पोलर सिंपली मीन्स चार्ज डिस्टॉर्शन, चार्ज सेपरेशन। एक ऐसी स्थिति जहाँ मॉलिक्यूल का एक भाग नेगेटिव है और एक भाग पॉजिटिव है, यानी कि दोनों चार्जेस हैं मॉलिक्यूल में। जैसा कि आप इधर देख सकते हैं, ब्रोमीन इज पार्शियली इलेक्ट्रोनेगेटिव व्हाइल कार्बन इज पार्शियली इलेक्ट्रोपॉजिटिव, एंड दिस इज कॉल्ड अ पोलर बॉन्ड, आल्सो कॉल्ड द डाइपोल। नाउ सिंस CBr bond is highly polar, and its high polarity is also attributed to the negative inductive effect of bromine and the positive inductive effect of the 3 methyl groups which are here attached to this carbon. As a result, this molecule, the CBr bond, undergoes heterolytic fission in the polar solvent to form a carbocation. So see, CBr bond is a polar bond, and it is polar because of negative inductive effect of bromine and the positive inductive effect of the 3 methyl groups which are having positive inductive effect. So this I have shown with the arrow, the positive inductive effect, making CBr bond undergo heterolytic fission in polar solvent like water. See this, I have made a broken line which is simply showing the heterolytic fission, that is the process of fission has started. Such a state where processing is going on but nothing has happened finally, it's only a process, it is a transit, it is a passage. Such a stage in a molecule is called transition state. So this is basically a transition state where bromine is electronegative partially and this is partially positive. Now children, finally, the CBr bond breaks, cut, and we get a carbocation, that is the third butyl carbocation, which is formed in step 1. So what you should keep in your mind is, in SN1 mechanism, first of all, SN1 will happen only with the bulky alkyl groups, that is very prompt in a tertiary alkyl halide. And in this process, in step 1, the CBr breaks and makes the carbonium ion or the carbocation. But before forming the carbonium ion or the carbocation, a transition state is formed in which partial fission of the bond between carbon and bromine takes place. Partial fission of the bond between carbon and bromine takes place, in which the carbon acquires the partial positive charge while the bromine acquires the partial negative charge. Children, carbonium ion is comparatively more stable than the transition state. This step 1 is a slow step. It is a very slow step, and as you know, according to kinetics, the slow step is the rate determining step. So this is the RDS, the rate determining step, and hence if this step is rate determining step, and as you know law of mass action, rate depends directly on the concentration of reactant, and in the rate determining step, the main reactant is the substrate. So rate of this reaction is directly proportional only to the molar concentration of third butyl bromide, and so it is a first order reaction. Now children, we go to the next step, that is the step 2. As we know, SN1 reaction takes place in 2 steps, of which we are done with step 1. So we now move to the second step, step 2. Students, in the second step, there will be formation of COH bond. As you know, in the step 1 there was breaking of CBr टूट के कार्बोकैटायन बन गया. अभी कार्बोकैटायन क्या करेगा? वो बॉन्ड बनाएगा OH के साथ. So formation of COH bond. So that is our second step. Okay. Now we take the carbocation. We know carbocation is sp2 hybridized with a bond angle of 120 degree. The carbocation is equally open from all the sides, having an angle of 120 degree, 120 degree here and 120 degree here, and it is sp2 hybridized. Now this geometry makes it very, very special. How it becomes very, very special? The attack of nucleophile on the carbonium ion takes place first of all very, very fast. Zup! Attack. Why it is very fast? Because you can see nucleophile is negative and this carbocation is positive, so they react very fast and it requires very less activation energy because opposite charges they attract. Now nucleophile can attack the carbocation from the front as well as from the back because of the geometry of carbocation, and we get again a transition state where the bond is not formed but it is forming. That is, the processing is going on for the formation of COH bond, which we are indicating with the broken line. It is not a broken bond. If the bond is not breaking, the bond is getting formed, but it is partially happening slowly. The bond is getting formed. Now, this is the second transition state which is formed, in which carbonium ion forms a loose combination with OH. In this, carbon acquires partial positive charge while the OH acquires a partial negative charge. Finally, products are formed, as we saw that the nucleophile can attack from the front side as well as from the back side as that of the place of the leaving group. So, when the attacking group OH comes on the same side as the leaving group, then it is called retention of configuration. It is called retention of configuration, and there can be one more arrangement where the attacking group comes on a side opposite to the leaving group because nucleophile is attacked from the back side. So this is called inversion of configuration, and usually it is 50% retention and 50% inversion, but very precisely when we see inversion is little more than retention. So inversion is little more than the retention. So these are the 2 steps for SN1 reaction. Now students, we go to the next type of reaction, and that is the SN2 reaction, that is the SN2 mechanism. One thing which you already know is in SN2 we will not take a alkyl halide with a bulky group because bulky group favors SN1. So meanings we will see first. S stands for substitution. You all know this. N stands for nucleophile. 2 means second order kinetics. So children, in the term SN2, S stands for substitution, N stands for nucleophile, and 2 stands for second order kinetics. Second order kinetics means the rate of this reaction is directly proportional to two type of things. One is the substrate and other is the reagent. So SN2 reactions or SN2 mechanisms are those reactions in which rate of reaction is directly proportional to the molar concentration of substrate as well as the reagent. As we know, in SN1 we took tertiary substrate. Obviously here we'll be taking a primary substrate, say methyl bromide, and the reagent, which over here will be same KOH. So this is how rate is represented for the SN2 reaction. Now the steps of SN2 reaction. Children, SN2 reaction takes place in only one step. SN2 takes place in only one step. Just one step. Okay. Now, the one step which is over here actually involves 3 stages. Now, stages don't mean the step. It involves 3 stages. That one step involves 3 stages. Let us see what. The first stage is the backside attack of the nucleophile. First stage is the backside attack of nucleophile. Now what do we mean over here? See, when we have CH3Br, now whether this is methyl or it is tert-butyl, when OH minus approaches from front, it can't approach. OH minus attacks from front, it is repelled back. Why it is repelled back? Because it's very simple. The OH minus will not attack the molecule from front in order to avoid the electrostatic force of repulsion between the weak nucleophile Br minus and the strong nucleophile OH minus. And hence the stronger nucleophile attacks from back. Attack. This is called backside attack of the nucleophile. The next stage over here, students, is formation of transition state. The next stage is called formation of transition state. Let's see what happens in this formation of transition state. Now, we know due to approach of the nucleophile from the backside, as you see over here, the CBr bond gradually weakens and the COH bond gradually strengthens like this. Correct? This leads to formation of a transition state with OH partially negative, CBr partially negative in one axis, that is the linear axis, that is in one straight line, while the 3 hydrogen atoms, 1 and 3, while the 3 hydrogen atoms lie in a plane perpendicular to the OH-CBr axis. And the HCH bond angle over here is 120 degree. The HCH bond angle is 120 degree. The transition state, this is the transition state. This is a state of very high energy and maximum instability. Obviously, ये बीच की स्थिति है, ना तो प्रोडक्ट है ना तो रिएक्टेंट है, तो ये बेचारा तो हाईली अनस्टेबल होगा. सो ट्रांजिशन स्टेट इज अ स्टेट ऑफ maximum energy and minimum stability. This transition state is also called activated complex. The transition state is also called activated complex. And in this complex, this carbon has equal attraction for OH and Br. So partial negative charge on OH and Br in this transition state where carbon is pentavalent. Carbon is pentavalent? What am I saying? Carbon is pentavalent? Yes. Since carbon is pentavalent in this transition state, this has to be highly unstable. And hence, the molecule breaks one of its bond, which is the Br bond, which is broken, and that is the third stage, which is called inversion of configuration. That is the third stage, which is called inversion of configuration. The third stage, which is called inversion of configuration, where the CBr bond breaks and the COH bond takes its position. Since the nucleophile attacked from the back side, the product has a nucleophile exactly opposite to the leaving nucleophile. This is called 100% inversion. 100% inversion in configuration, also called SN2 inversion, also called Walden inversion, also called SN2 inversion, also called Walden inversion. I'll just write little up. Walden inversion, and children, this is also called umbrella inversion. It's also called umbrella inversion. So that was SN2. You can see to initiate we need the nucleophile. बिना न्यूक्लियोफाइल के कुछ नहीं होगा, इसलिए न्यूक्लियोफाइल की मात्रा यहाँ ज़्यादा होती है. And the rate depends on molar concentration of both the substrate and the nucleophile. So children, here I have completed the explanation of SN1 and SN2 reactions. And now we proceed to elimination reaction. I hope you are not bored. You shouldn't be, in case you want to understand the process, because breaking this video into many parts and finally reaching a conclusion won't make much of a sense. Attending it all over once will really be very, very beneficial. Now we come to the elimination reaction, that is the E type of reaction. Again, we have got two categories of student. One of the category is the E1 and the other category is the E2. By E1 I mean elimination of the one type, and E2 is elimination of the second type. Now let us see what is E1 reaction. We know, children, alkyl halides undergo alkyl halides. We've seen in this video only. In this video, in the beginning, we have learned alkyl halides undergo beta elimination reaction in presence of potassium hydroxide in ethanol to yield an alkene, because the OH minus, which is now functioning as a base, can abstract a proton from the beta hydrogen since it is not a hydrated ion. This process can take place in two ways. One of the way is E1 and the other one is the E2 mechanism. According to the structure of alkyl halide, just listen carefully what I said. The elimination reaction can take place in two ways, E1 or E2, depending on the structure of the alkyl halide. Now, when I take say a molecule of, or first let's just understand E1 over here stands for what. E1 stands for, let's just see the meanings. E1 stands for elimination, that is elimination unimolecular reaction. It stands for elimination unimolecular reaction because
Same reason, the rate of reaction depends only on the concentration of the alkyl halide. For example, if I take tert-butyl bromide, or say I am taking chloride, but the reagent is also KOH, but the medium is alcoholic, ethanol, ETH, ethanol. Now, in this case, we get the base abstracts a proton from beta carbon. It can abstract proton from any of these beta carbon, any one at a time, any one beta carbon, because all have same number of hydrogens. They are all primary carbons. And we get this structure, which is 2-methyl propene, and the byproduct is KCl and a molecule of water. So, tert-butyl bromide when reacted with alcoholic KOH, then we get isobutylene as the product, and the byproducts are KCl and a molecule of water. Now children, the rate of this reaction is directly proportional to only the concentration or the molar concentration of the substrate, and hence it is E1. Okay, now E1 reaction, that is elimination of the one type, takes place in 2 steps. This takes place in 2 steps. It takes place in 2 steps. And the step 1 is, let us see step 1. Step 1 is, in this step, tert-butyl carbocation is formed. See how? This is tert-butyl chloride. This is a slow process, which I am indicating by a reversible arrow. It is quite a slow process. It gives me, rate always depends on the slowest step, and hence rate depends on the concentration of substrate here, because this is the slowest step, and we get a tert-butyl carbocation and the chloride anion. This is step 1. In the step 2, students, what happens is, first of all, this is a very fast step. Okay. Now what happens over here is, this tert-butyl carbocation which is formed, I'm just writing one H separately to understand the process. That is, on the beta carbon I've written one H separately, and there's a positive here on the carbon. This is a first step in which the base, okay, which is behaving as base in alcoholic medium, the base removes a proton, that is, the base OH minus, which is having an electron pair, attacks H, which is not in the form of a H, but it has lost its electron to beta carbon, and so it is a proton. So the base abstracts a proton from the beta hydrogen and forms an elimination product. This bond goes to carbon, and finally it makes a pi bond over here. So the alkene 2-methyl propene or isobutylene is obtained. And here I am writing the molecule of water, which is removed. This is that molecule of water which is gone. So these are the 2 steps in E1. Okay, this still here, I hope it is clear to you. Let us proceed further. सोने का नहीं है सुनने का है, lecture is big, so what? सोने का नहीं सुनने का है, सोना नहीं है सुनना है. Okay, now next, E2 elimination. You should be very alert in the class. Now the E2 type reaction. Students, here E2 stands for elimination by molecular reaction. E2 stands for elimination by molecular reaction. E2 stands for
elimination by molecular reaction, because the rate of this reaction will depend on molar concentration of both alkyl halide and the base. Let us look at an example. Say we take this molecule, okay, and we take alcoholic KOH, heat, we get propene, KBr, and a molecule of water. Okay. Now let us see how this step takes place. But here I'll just mention one thing. Rate is directly proportional to molar concentration of not only the alkyl halide but also the base. Since rate depends on both the type of reactants, that is substrate as well as reagent, this is a two-type reaction, that is E2. Now, how is the mechanism here? Let us see. Students, here I am taking the molecule of 2-bromo-propane, and I'm writing all the hydrogens separately just to understand it better. I'm writing all hydrogens separately. Okay. Now what happens is OH minus, which is now behaving as a OH minus, which is now behaving, I'm just writing this 2 here because it should not get congested. Now this OH minus is behaving as a base. Okay. Now the OH minus attacks the H, and the electron pair over here is withdrawn to this place, and the Br is out with this electron pair. Each bond has 2 electrons. So what happens is, what we get is something like this. See, I'm writing everything. We go stepwise because I'm telling you the mechanism now. Now see this point, partial double bond character I have shown. I have not broken or I have not formed any bond. I'm writing everything. This is C, breaking is in the process of getting weak. It is, the bond strength is reducing, so broken line, and nothing happens on the next carbon, so all H I wrote. Here also there is a bonding taking place with the nucleophile taking place. Okay, and this is that nucleophile. So nucleophile attacks the proton, the electron pair will be partially moving here, and that is moving here, and this will be removed. Okay, and finally we get something like this, because this takes the proton. See, I have not taken the bond will go here. So I have not taken the bond will go there. So this is how water is removed. This was the sigma bond. This entire bond comes here. So now a pi bond is formed. C, H. The process of breaking is over. It breaks and it is lost. It is kicked out. Get lost. I'm telling Bia, not you. You be there. Understand the lecture. Okay. So this is propene and water molecule formed. So this is how elimination is taking place by E2. I hope you remember the Sedzeff's rule. In the same molecule, instead of 2-bromo, if I would have taken, instead of 2-bromo-propane, if I would have taken 2-bromo, say let us take butane, then students, we would have got 2 products. I hope you remember. One of the product is but-2-ene, and the other product is but-1-ene, where this is 81% and this is 19%. But-2-ene can further
be broken into trans-butene and cis-butene, where the trans isomer, its trans isomer will be 71%, while the cis isomer will be only 10%. The trans is more stable than the cis isomer. And this is as per Sadzev's rule, and the Sadzev's rule states that more substituted alkene is the major product during beta elimination. Now students, we have come a really long way. We've discussed really a lot of things by now. What we should understand is how there is competition, between elimination versus substitution. The most important thing and interesting too. Not difficult. According to me, there is nothing difficult in chemistry. Chemistry is simple. And see, my name is Simple Shukla, so everything is simple now. Okay. Now, elimination versus substitution. I'll just write here. Elimination versus substitution. Elimination versus substitution. Let us see. Okay? Elimination versus substitution. Now, elimination and substitution reactions are highly competitive. They're very competitive. That is, one reaction occurs at the cost of other. That is, one reaction occurs at the cost of other. One reaction occurs at the cost of other. And the course of reaction depends on structure of alkyl halide. The course of reaction depends on the structure of alkyl halide. It also depends upon the nature of the solvent, the type of the leaving group, correct? And the reagent, how it behaves as a nucleophile, and how and when, in which condition the nucleophile, that is the reagent, the same reagent will behave as a base. Now students, it is found that proportion of elimination increases as the structure of alkyl halide changes from primary to tertiary. Once again, I am repeating, the proportion of elimination increases as the structure of alkyl halide changes from primary to tertiary. If the reactant is primary alkyl halide, then it would undergo E2 or SN2 reaction. But if the reactant, that is the substrate, is a secondary or a tertiary alkyl halide, then it will undergo E1 or SN1 reaction. Or it may also undergo E2 or SN2 depending on other conditions of solvents. Now children, we see these categories in detail now, because just by theory it will not be clear. Take some examples, but time being I just give you the order. See, a 3-degree alkyl halide is more reactive than a 2-degree alkyl halide, then a 1-degree alkyl halide, then the methyl halide. And basically, to be very frank, methyl halide cannot undergo elimination, because in elimination a pi bond is formed and there is no beta carbon in methyl halide to form a pi bond. So children, this is, I'll just write this properly, it will look like B. Okay, so over here, methyl halide will not undergo elimination. So it's most feeble. In fact, I'll say it doesn't undergo elimination only. So this is the order for E1 and this is the order for E2 reaction, that is elimination type 1 and elimination type 2 reaction. Okay. Now next comes SN1. We took the example of tertiary alkyl halide in SN1. So it's very clear. For SN1 reaction also the order is this. That is primary alkyl halide is more reactive towards SN1, then secondary, then primary. The tertiary alkyl halide is more reactive towards SN1, then secondary, then primary, then methyl. And when we come to SN2 students, obviously we took methyl bromide, so it's very clear SN2 is at its best with methyl bromide, and then we can take a primary alkyl halide, then secondary, and the reaction will be very, 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 very feeble when I want to do SN2 with a tertiary alkyl halide. So that is in general the order I have given. Now we just see how solvents play a role in deciding which type of reaction. So let us see that, the role of the solvent in deciding the type of the reaction. So I just erase this. Where's the duster? Yeah. Okay, now the next funda which we come to is, just a minute, I'm just getting the chalk. Yeah, now students, we want to understand how does a solvent play a role in deciding substitution and elimination. See, solvents play a major role in type of reaction that will take place. Solvents play a major role in the type of reaction that will take place, and students, solvents are of three types. They can be polar protic solvents, the polar protic solvent, it can be the polar aprotic solvent, and it can also be a non-polar solvent. So solvents are basically of three types: the polar protic solvent, the polar aprotic solvent, and the non-polar solvent. Now let us just see them one by one. So we take polar protic solvent. First understand what does it mean. Polar protic solvents are those solvents which have a tendency to produce. Polar protic solvents are those solvents which have a tendency to produce proton. That is, they release protons, and they also have a tendency to form hydrogen bonds. They have tendency to form hydrogen bonds. And these polar protic solvents especially form hydrogen bond with electronegative atoms, that is fluorine, oxygen, nitrogen, in this order. Tendency to form hydrogen bond with fluorine is more than that of oxygen, which in turn is more than that of nitrogen. Now students, one very important thing which we need to know here is, how do I understand who will make hydrogen bond? See, these are those molecules which have a hydrogen directly attached to fluorine, oxygen or nitrogen, where fluorine will not be of much importance with us, but any molecule which will be having a OH bond or a NH bond will have a tendency to make hydrogen bonds and will release protons, and such are the polar protic solvents. Now, how do these solvents behave, and how do they release hydrogen, and how are they how do they release proton, and how are they polar protic? That is what we need to understand. So for example, I take molecule of water. I take a molecule of water, and as you all know, water is a universal polar solvent. We all know water is a universal polar solvent. Why water is polar? I'll just revise that. See, this water molecule. This is the lone pair on oxygen, another lone pair on oxygen, the one electron of oxygen shared with hydrogen, and here hydrogen. Now, why this is polar? See, पोलार मॉलिक्यूल कौन सा मॉलिक्यूल होता है जिसमें दो प्रकार के चार्ज होते हैं, यानी कि जिसका एक हिस्सा नेगेटिव होता है और एक हिस्सा पॉजिटिव होता है. अगर आप वाटर को ध्यान से देखेंगे तो वाटर में ये जो हाइड्रोजन है, दिस इज इलेक्ट्रोपॉजिटिव पार्ट ऑफ द मॉलिक्यूल, और ये जो ऑक्सीजन है, दिस इज द इलेक्ट्रोनेगेटिव पार्ट ऑफ द मॉलिक्यूल, एंड हेंस वाटर हैज बोथ द चार्जेस. दिस इज द partial positive charge of hydrogen, and this is the partial negative charge of oxygen, and hence I can say water is polar and water is having a dipole. Now it is because of this polarity water can form the hydrogen bond. See how water forms hydrogen bond. When I take a molecule of water, say HOH, then this H of one water molecule which is electropositive, oxygen is electronegative, this H which is electropositive attracts oxygen of another molecule of water like this, and the H over here which is electropositive now again attracts oxygen which is electronegative of another molecule of water, and this is how they go on bonding with each other. And these bonds, these broken bonds which are made, are nothing but the intermolecular hydrogen bonds. I'll just write this little up. This is H here, and I think now it is clear. This is also a H over here. So this is how the intermolecular hydrogen bonds are formed. Fine. Now, hence we can say a polar protic solvent is a solvent that has a hydrogen directly bonded to oxygen or nitrogen, but not to sulfur, carbon, alkyl or aryl groups. Once again I repeat, hence a polar protic solvent is a solvent which has hydrogen directly bonded to oxygen, nitrogen, but not to sulfur, carbon, alkyl or aryl. And hence I can say good polar protic solvents. We just saw why water is polar. So students, good polar protic solvent is water, is ammonia. They are good polar protic solvents, and we can also take something else like alcohol, amine, which are a little larger, and they are also okay polar protic solvent. Okay, they can also be used as polar protic solvents. Now, since polar protic solvent has a polar protic solvent, since a polar protic solvent has partial negative and partial positive charge on every solvent molecule. Say when I take water, then every water molecule has positive and negative. Every water molecule has the electronegative and the electropositive. So since in a polar protic solvent, every solvent molecule has partial negative and a partial positive charge, they have a good ability to dissolve the charges of the carbocation. They have good ability to dissolve the charges in solution. यानी एक पोलर प्रोटिक सॉल्वेंट के पास उसके हर मॉलिक्यूल में इलेक्ट्रोनेगेटिव भी है, इलेक्ट्रोपॉजिटिव भी है, यानी कि उसके हर मॉलिक्यूल में पॉजिटिव चार्ज भी है, नेगेटिव चार्ज भी है. इसकी वजह से उसमें एक अच्छी क्षमता है सॉल्यूशन के चार्जेस को डिसॉल्व करने की. Now why I said carbocation in between. Children, if you remember,
In SN1 and in E1 mechanism, the intermediate was carbocation. और एक पोलार प्रोटिक सॉल्वेंट में अच्छी क्षमता है चार्ज को स्टेबलाइज करने के लिए, यानी एक अच्छे कार्बोकेटायन का अगर निर्माण करना है, इफ यू वांट टू मेक अ गुड कार्बोकेटायन, वी नीड अ गुड पोलार प्रोटिक सॉल्वेंट, एंड हेंस वी कैन से E1 and SN1 are favored in a polar protic solvent. Let us see how do they stabilize the carbocation. किस तरह से वो कार्बोकेटायन को बनाने में मदद करते हैं वो देखते हैं. ये हमारे पास कार्बोकेटायन है जिसके पास पॉजिटिव चार्ज है. Water is a polar protic solvent, that is why this carbocation positive charge attracts the oxygen, negative oxygen, that is the electronegative oxygen of water. क्योंकि वाटर में इलेक्ट्रोनेगेटिव इलेक्ट्रोपॉजिटिव दोनों चार्ज है, इसलिए वो पोलार है और ये एक पॉजिटिव आयन है और ये इसको अट्रैक्ट करता है बाय द आयन डाइपोल इंटरैक्शन. Similarly, this will attract water from the other side also, and hence the molecule is, the carbocation is totally blocked, totally caged, totally stabilized, and hence formation of carbocation will be faster in the polar protic solvent. Not only this, when carbocation is formed in SN1 or E1, we know Br minus is formed. Now this Br minus is also, its charges are also dissolved by water. See how it attracts the H of water like this. It attracts the H of water like this, and so on. It attracts the H of water. It attracts the H of water like this, and hence we know that these intermediate becomes stable. The carbocation intermediate becomes highly stable. It means it is formed क्योंकि जब वो बनेगा तो ही आगे किसी से रिएक्ट करके आगे का रिएक्शन होगा. And hence we understood that a polar protic solvent will stabilize the charges, it will stabilize the carbocation, it will stabilize the leaving group, and the breaking of CBr will take place properly in a polar protic solvent. So the polar protic solvent will favor SN1 and E1 reaction. While if I see E2 and SN2 reactions, E2 and SN2 reactions, just writing here E2 and SN2 reactions. So when I take E2 and SN2 reactions, E2 and SN2 reactions, they are not favored in the polar protic solvent. Why? These reactions SN2 and E2 are unstable in polar protic solvent because a strong nucleophile will be blocked on its way to attack the molecule. See, in SN2 or in E2, just I am taking this example, ethyl bromide, what happens is the nucleophile attacks the molecule from the backside. Okay. Now, my dear children, if it is having a polar protic solvent, then the nucleophile will make bond with H of water from all sides. The nucleophile will make bond with the H of water because water, a hydrogen is electropositive. Same thing here, and you can understand. You can go on writing. I'm not writing more number of water now surrounding it. Now, because nucleophile is surrounded with water in a polar protic solvent, its way will be blocked to attack the molecule, and hence SN2 will not be favored in a polar protic solvent. Now, on the other hand, children, if I see E2, although I wrote here, it is not that favored, but to some extent E2 can take place. See why? I have here the ethyl bromide, same thing I am taking, and this is the alpha carbon, this beta carbon. Okay, now
when I take OH minus in water, it doesn't create much of difference, although it'll be slow, but it still can happen. Why? This OH minus can take proton from this water, and this OH, when it takes proton from water, OH becomes water, but water becomes OH. सीधी बात है ना, OH माइनस ने अगर यहाँ से एक हाइड्रोजन लिया तो ये H2O हो जाएगा और ये OH रह जाएगा, तो किसी भी हालत में OH माइनस तो होगा ही, so it can abstract this beta hydrogen and elimination can take place and we can get the product alkene. Correct? And hence I can say polar protic solvents will finally favor polar protic solvents. I am writing here polar protic solvent, that is PPS, will favor E1, will favor SN1, will favor E2, but will not favor SN2. That is, writing again, just be attentive, a polar protic solvent will favor E1, SN1, E2, but not SN2 reaction. I hope students it's clear till here. We have come a long way in the lecture, really long way, little more to go. Let us proceed. Now the next type of solvent which is taken over here is the polar aprotic solvent. The next category of solvents, students, is the polar. They are polar, they have electronegative and electropositive charge, that they have a dipole, but they are aprotic. A means without. Protic, proton. ये solvent proton produce नहीं कर सकता है. They are polar but aprotic. Some of these solvents are DMSO, that is dimethyl sulfoxide, whose structure is like this, dimethyl sulfoxide. See, now if you take care, this is electropositive, this is electronegative, so this is polar in nature, but there is no hydrogen attached to oxygen, nitrogen, fluorine, and hence ये proton नहीं दे सकता, इसलिए ये polar aprotic है. Same way we can take methyl cyanide. Methyl cyanide में भी polarity है, ये polar है, लेकिन ये भी हाइड्रोजन नहीं दे सकता, इसलिए ये भी polar aprotic हुआ. फिर अपने पास एग्जाम्पल है DMF, मैंने इसका नाम नहीं लिखा, आई थिंक आपको आता होगा, मिथाइल साइनाइड. So sometimes if I don't write certain things, it's okay. If you have any doubt, you just drop it in the comment box. Now DMF is dimethyl formamide. See what is dimethyl formamide? This is the formyl group, and amide, where the two hydrogens are replaced by methyl. So this is also polar, electropositive, electronegative, but it is not having a proton that can be released. And we can also take the example of acetone. Acetone is also polar aprotic solvent. This is electronegative, this is electropositive, this is also polar, but no hydrogen bonded to oxygen, nitrogen or fluorine, so it cannot give a proton. So since none of them have a OH or a NH or a HF bond, and hence they are polar aprotic, they cannot release protons, they cannot form hydrogen bonds. And the polar aprotic will favor SN2, obviously, because polar protic solvents stabilize carbocations in E1 and SN1, and also they allow E2 to happen because it can abstract a proton. So polar protic solvents favor SN1, E1 and E2, while the polar aprotic solvent favors SN2 mechanism. Now children, there is another type of solvent, and that is the next category of solvents is the non-polar solvents. The next category of solvents is the non-polar solvents, and children, in this category of non-polar solvents we can have something like toluene, we can have N-hexane. Now these are the examples of non-polar solvents. These solvents are hydrophobic in nature. They will not block the nucleophile. They do not block the nucleophile, obviously, because to block the nucleophile we need polar. भाई नेगेटिव को स्टॉप करने के लिए पॉजिटिव चाहिए ना, तो पोलार में पॉजिटिव नेगेटिव दोनों होगा. अभी देखा हमने थोड़ी देर पहले इसी वीडियो में. तो they will not be able to block the nucleophile. These solvents cannot stabilize the carbocation, so they cannot, so the leaving group X negative cannot leave. तो जब लीविंग ग्रुप निकलेगा ही नहीं तो नया ग्रुप आएगा कैसे? Hence possibility of SN1 E1 बिल्कुल खत्म हो जाती है, क्योंकि कार्बोकेटायन ही नहीं बनेगा. And SN1 and E1 has carbocation intermediate. But as far as SN2 and E2 is considered, they will be favored. SN2 and E2 will be favored. Why? Because as such in SN2 and E2, leaving group does not leave on its own, but the backside attack of the nucleophile makes the leaving group forcefully leave the molecule. So that can happen in a non-polar solvent. So children, you have seen how the nature of solvent is also important along with the nature of the alkyl halide to understand whether SN1, SN2, E1 or E2 mechanism will take place. Now, another important thing which is over here is the leaving group. The type of the leaving group also tells which type of reaction SN1, SN2, E1, E2 will take place. First of all, leaving group means the one who leaves. Common sense. The one who leaves. So leaving group is a group which leaves, just gets lost, kicked out, thrown out. Now students, a good leaving group, something very important I am writing, a good leaving group, a good leaving group is a good leaving group is a weak base. A good leaving group is a weak base. Weak base is actually conjugate base of weak base is a conjugate base of now it's fine. Weak base is a conjugate base of strong acid. Say for example, I take acid HCl, which is a very strong acid. When the acid dissociates, the electron pair is taken by chlorine and Cl minus nucleophile is formed and H plus here. Now children, HCl has more tendency to lose a proton than chloride having the tendency to accept back the proton. Since this has a tendency to lose proton and hence according to Bronsted theory, it is a very strong acid. Cl minus has a tendency to accept proton but very feeble, very weak tendency, and hence it is the weak conjugate base of strong acid HCl. This is what I mean by saying the statement that the good leaving group is a weak base, that is the base which is the conjugate base of the strong acid. Say for example, students, we take I minus and we take Cl minus. Now out of these two, let us see who is a good leaving group. Now out of I minus and Cl minus, I minus is a good leaving group while Cl minus is a okay leaving group. Good leaving group, and this is okay, so leaving group. Why I minus is a good leaving group? Because this is a larger anion, and say if the solvent is polar protic, that is अगर इसके आजू बाजू पानी है तो वो पानी क्या करेगा? वो पानी इसे काफी दूर से अट्रैक्ट करेगा. कारण क्यों दूर से अट्रैक्ट करेगा? क्योंकि इसमें 5 शेल हैं, इसके पास 5 शेल हैं. तो पानी का मॉलिक्यूल इसे काफी दूर से अट्रैक्ट करेगा, लाइक दिस. ये इलेक्ट्रोपॉजिटिव, ये इलेक्ट्रोनेगेटिव, ये इलेक्ट्रोपॉजिटिव. So what a molecule will attract it from a distance. And hence इसको जो हमें एक बोलते हैं ना केज बनाया जाएगा, एक जो ब्लॉक बनाया जाएगा पानी का, ये काफी दूर से बनेगा. इस कारण से इसका वो जो ब्लॉक है वो आसानी से तोड़ा जा सकता है, एंड इसीलिए ये एक बहुत ही अच्छा लीविंग ग्रुप होगा. लेकिन सबसे मेन बात जो ध्यान में रखनी है वो ये है कि ये एक बहुत ही अच्छा लीविंग ग्रुप होगा, लेकिन कहाँ, किधर? इट विल बी अ गुड लीविंग ग्रुप, बट कहाँ? इन द प्रोटिक सॉल्वेंट. और जो Cl माइनस होगा वो एक ओके लीविंग ग्रुप होगा, क्योंकि ये छोटा है, इसके पास 3 शेल्स हैं. 3 शेल होने की वजह से पानी इसे बहुत नजदीक से अटैक करता है, और इस कारण से ये ओके लीविंग ग्रुप है. यानी Ri बॉन्ड ज्यादा जल्दी ब्रेक होगा पोलर प्रोटिक सॉल्वेंट में, लेकिन Rf बॉन्ड जल्दी ब्रेक होगा पोलर अप्रोटिक सॉल्वेंट में. यानी ऑर्डर ऑफ रिएक्टिविटी हुआ Ri greater than, or we will not write R, we can say I minus greater than Br minus greater than Cl minus greater than F minus in polar protic solvent, और जो कि इसका बिल्कुल ऑपोजिट हो जाएगा, F minus greater than Cl minus greater than Br minus greater than I minus in a polar aprotic solvent. In a polar, होप अभी दिख रहा है सबको, पोलर अप्रोटिक सॉल्वेंट. ओके, तो ये हो गया लिविंग ग्रुप की स्टोरी. अब यहाँ पे एक और चीज समझनी है, वो यहीं पे एक्चुअली कवर हो गया हमारा, वो था टाइप ऑफ हैलोजन. जैसा कि आपने देखा, अगर हैलोजन फ्लोराइड है तो फ्लोराइड का चार्ज बहुत ज़्यादा कॉन्सेंट्रेट होगा उसके ऊपर इन अ पोलर अप्रोटिक सॉल्वेंट, तो ये अच्छा बिहेव करेगा, अच्छा रिएक्शन देगा, जबकि पानी में I माइनस ज़्यादा अच्छा रिएक्शन देगा क्योंकि उसका केज उससे काफ़ी दूर है, इस तरह से वो जल्दी आसानी से रिएक्ट कर सकता है, ब्लॉक नहीं होगा, एंड हेंस ऑर्डर ऑफ रिएक्टिविटी विल बी आयोडाइड ग्रेटर देन ब्रोमाइड ग्रेटर देन क्लोराइड ग्रेटर देन फ्लोराइड इन अ polar protic solvent, but the order of reactivity is fluoride greater than chloride greater than bromide greater than iodide in a polar aprotic solvent. Now students, in this entire lecture what we studied was I hope it was a good lecture and you really enjoyed the lecture. Oh, it was a very lengthy lecture, I'm really tired. Anyway, now see students, what we learned in this lecture was a lot of things, comparisons and comparisons and comparisons, and we are into the foundation to the building up of SN1, SN2, E1, E2, everything we completed. Now in this entire lecture what we understood was that halide was a weaker nucleophile which was replaced by a stronger nucleophile OH minus. What if I want to replace OH minus? Will it be replaced easily? Is OH minus is a good leaving group? No, not at all. Then how to make OH minus a good leaving group? That is what I'll be teaching in the next video, where we'll come across the mesylate and the tosylate and how they make OH minus a good leaving group, although it is not a good leaving group. We'll see that in the next video. Now student, if you have any queries with respect to this lecture, you can just put it in the comment box. If you have any problem with respect to chemistry, you can connect to me on my Facebook page, Simple Shukla's Private Tutorials. Stay blessed. Bye bye. Take care. Love and blessings to all of you.